Hello everyone, welcome back to Piece of Physics. In this particular video, we are going to solve some few problems related to the graphical representation of motion, right? Our first kind of problem is basically here. So the question is, figure shows x versus t graph. It is displacement versus time graph of a particle. Find the time t such that the average velocity of the particle during the period 0 to t is 0. Okay, so you can clearly see here that object is initially at 20-meter distance and it starts its motion and reaches at this particular point. Okay, and it is somewhere over here. Okay, so now we can find this particular time. Okay, this is 10, this is 20, this will be 15, and at this point this is 12 second. Okay, so basically t is 12 second. So that will be the particular answer. From 0 to 12 second, average velocity of the particle is 0. Okay, our next problem is a particle starts from point A and travels along the solid curve shown in the figure. Find approximately the position B of the particle such that the average velocity between the positions A and B has the same direction as the velocity at B, right? So here the particle is here, right? And this particular path represents some equation, which is basically this is y versus x graph, and this path represents some motion. Okay. So here we have to find a point here in this particular line where the average velocity and instantaneous velocity would have the same direction. Okay, so basically here this is the point. This will be the particular, this is the point B. Okay, so this is the direction of the average velocity, and at this point you can also find the uh, direction of the instantaneous velocity, basically which is in the direction of the tangent, right? So this particular point B. Okay, now we can find the coordinates of this point B, right? So if we extend this particular point like here, B, okay, this is 3 meter, 5 meter. Okay, so B is going to be 5 comma 3. Okay, so position B will have the coordinates 5 comma 3, and that will be the position where instantaneous velocity at B and average velocity between A and B will have the same direction. Okay, our next problem is a car starting from rest first moves with an acceleration of 5 meter per second square for some time. After moving with a uniform speed for some time, starts deaccelerating at the same rate to come to rest in a total time of 25 seconds. If the average velocity of the car over the whole journey is 20 meter per second, for how long does it move with a uniform speed? Okay, let us plot a graph like this. This time velocity versus time graph, right? So now the velocity is increasing linearly, will become uniform, and it will decrease linearly, right? Okay, so here so here they have said that total time for the this particular motion is 25 seconds. Okay, I'll take this particular time as t, and it is also deaccelerating with the same acceleration, so time to come to rest also will be t. So here this time is t and this time is t, so this will be 25 minus 2t, because we have two time interval t and t here. Okay, so now let us calculate total distance. Okay, so here you can see that this is 25 seconds and this is 20 meter per second. We have average speed equals to total distance divided by time. It will give distance equals to velocity into time. Okay, average velocity into time. So distance will be basically 20 into 25, so 500 meters, right? Okay, so now the area under this particular graph will give us the total distance, which is 500 meters. 500 equals to, okay, we'll get half 5t into t plus half 5t into t plus is 25 minus 2t into 5t, right? This is 500. This is half 5t square plus half 5t square plus 25 into 5 is 125 t minus this is 80 square, right? Okay, so here you can see that this is 500 and 5t square by 2, 5t square by 2 will be 5t square, right? And this is minus 10t square plus 125t, right? Now this is 500 and 5t square minus 10t square will be minus 5t square plus 125t. Okay, so this 5t square minus 125t minus 500 equals to 0. Okay, this will be t square minus 25t minus 100 equals to 0. Okay, so here now we are going to solve this particular quadratic equation. So we'll get t equals to minus b, so this is the b, so it will be 25 plus or minus b square minus 4ac, so b square is 25 whole square minus 4, a is 1 and c is minus 100 divided by 2. Okay, so you will get t equals to 25 plus or minus, this is going to be 625 plus 400 divided by 2, right? We have made one mistake over here, so this is basically plus plus plus, this would be minus. Okay, so this is 25 plus or minus, this is 25 by 2, so this will be 25 plus or minus 15 by 2. So we will have two answers, like 25 plus or minus 15. Okay, so one take plus and one take as 40 by 2 is 20 and 10 by 2 is 5 seconds. Okay, so this is 20 and this is 5, so value of t is 20 and 5. Now you can see that this value is not possible, so value of t should be 5 seconds. Okay, now you can see that we have to find this particular time interval, 25 minus 2t. Okay, so this will be 25 minus 2 into 5, so this will be 25 minus 10, this will be 15 seconds. Okay, so for 15 seconds the object will move, car will move with the uniform speed. Our next question is, a car accelerates from rest at a constant rate alpha for some time, after which it deaccelerates at a constant rate beta to come to rest. If the total time left is t seconds, evaluate the maximum velocity reached and the total distance traveled. Okay, basically here we have to plot a graph of velocity versus time. Okay, so velocity is increasing linearly, and after that is decreasing with acceleration beta. This is alpha, this is beta, right? Now This is T1, this is T2, right? So here you can see that object initially was at rest, is 0. So here the object accelerates with the acceleration alpha for time t1, and at this particular point velocity is vm. Okay, so we can say that acceleration alpha will be equals to vm upon t1. So here from t1 will be equal to vm upon alpha, and here you can see that beta will be equals to vm on t2, so that t2 will be equal to vm upon beta, right? So the total time is t, which is happens to be t1 plus t2. So t equals to vm upon alpha plus this is vm upon beta. T is basically vm by alpha plus 1 by beta, right? T is basically vm, and this is alpha plus beta divided by alpha beta, right? So maximum speed will be alpha beta t divided by alpha plus beta, right? So this is the maximum speed. Okay, now we have to find total distance traveled, right? So for that we know that here the maximum speed is alpha beta t divided by alpha plus beta, and this particular base basically total time is t. Okay, so as we know that velocity times graph, area under the velocity time graph give us the total distance traveled, right? So distance will be half base is basically t, so alpha beta t by alpha plus beta. Okay, so this is going to be alpha beta t square divided by 2 alpha plus beta. Okay, so total distance traveled will be alpha beta t square divided by 2 into alpha plus beta. Okay, so that will be the answer of the second part of this particular question. uh, so that's all for this particular video, and stay connected to the channel for further videos. Thank you so much.